Myself, S.C.K2, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology, Solapur. Today, I am going to discuss the AC fundamentals. Learning outcome. At the end of this session, students can apply the knowledge of AC fundamentals to analyze the AC circuits. Alternating voltage and current. A voltage which changes its polarity at the regular interval of the time is called as a alternating voltage. When the alternating voltage is applied in a circuit, the current flows in one direction and then in the opposite direction. The direction of current at any instant of the time is depends upon the polarity of the voltage. Now here, in this circuit, when the AC voltage is applied, so current flows in the clockwise direction during positive half cycle, and during negative half cycle, the current flows in anti-clockwise direction. As we know, the commercial alternator produces the sinusoidal alternating voltage, that is sine wave. A sinusoidal voltage can be produced by a rotating coil with a constant angular velocity omega in the uniform magnetic field. The sinusoidal alternating voltage can be expressed by the equation V is equal to Vm sin omega t, where V is the instantaneous value of the alternating voltage, Vm maximum peak value, and omega is the angular velocity. The sinusoidal voltage always produces the sinusoidal current unless a circuit is non-linear. Therefore, the sinusoidal current is expressed as I is equal to Im sin omega t. This is the sinusoidal alternating voltage and the sinusoidal alternating current. At omega t is equal to 90 degree, the peak value is maximum. So here at omega t is equal to 90 degree, voltage is maximum, that is represented by Vm, and at omega t is equal to 270, the voltage is negative, maximum negative. Now, an alternating voltage may be generated by a rotating coil at constant angular velocity in the uniform magnetic field as shown in figure 1, or by the rotating coil at a constant angular velocity with a stationary coil as shown in figure 2. Here, consider figure 1. Here, the coil is rotated with a constant angular velocity in the uniform magnetic field. Now here the coil is rotating and here the coil is stationary. Here in this figure 2, the magnetic field is rotated with a constant angular velocity in the uniform magnetic. Here the magnetic field is rotated with a constant angular velocity and the coil is stationary. Now figure 1 represents that alternator and figure 2 represents the generator. As we know, the alternator and generator both are produces the AC electricity, but alternator produces AC electricity and the generator produces AC as well as DC electricity. Alternators are available in small size, generators are available in large size. Alternator produces small and medium voltage ranges, generator produces the large voltage range. So main difference is in the alternator the coil is moving and the generator coil is stationary. Now, in the both cases, generator voltage will be sinusoidal, and the magnitude of generator voltage will be depends upon number of turns of the coil, strength of the magnetic field, and the speed of the rotation. Now, consider a rectangular coil of n turns rotating in the anti-clockwise direction with the angular velocity omega in the uniform magnetic field as shown in figure 3. The EMF induced in the coil will be sinusoidal. Let the coil turn through an angle theta is equal to omega t in the anti-clockwise direction. Here, if the coil turn and coil is rotated in the anti-clockwise direction, in this position, the maximum flux phi max acting vertically downward can be resolved into the two perpendicular components. This is the flux acting downwards. The component phi max sin omega t parallel to the plane of the coil. It does not induce the EMF in the coil. The phi max parallel to the plane of the coil and the phi max cos omega t perpendicular to the plane of the coil, and the component phi max cos omega t perpendicular to the plane of the coil. This component induces EMF in the coil. Okay, the flux linkages of the coil at the considered instant, that is at 0 degree. So flux linkages is equal to N into phi. So number of turns into flux linkages. N phi max cos omega t. Phi max cos omega t is responsible for inducing the EMF. According to the Faraday's law, the EMF induced in the coil is equal to the rate of change of flux linkages of the coil. Therefore, EMF V at the considered instant is given by V is equal to minus d phi by dt. So V is equal to minus N phi max omega and cos omega t. Take the derivative of this. Therefore, V is equal to N phi max omega sin omega t. Now, here the value of voltage will be maximum only when sin omega t is equal to 1. Therefore, V max is equal to N phi max omega. Therefore, V is equal to Vm sin omega t and Vm is equal to N phi max omega. Therefore, V is equal to Vm sin omega t or V is equal to Vm sin theta. It is clear that EMF induced in the coil is the sinusoidal. That is, the instantaneous value of the EMF varies as the function of time, angle theta or omega t. Thus, a coil rotating with a constant angular velocity in the uniform magnetic field produces a sinusoidal alternating EMF. If the alternating voltage V is equal to Vm sin omega t is applied across the load, alternating current flows through the circuit, which would also vary sinusoidally. Therefore, the equation of alternating current is given by I is equal to Im sin omega t. What is the difference between alternator and generator? Alternators are available in small size and the generators are available in large size. Both are produce AC, but alternator produce AC electricity and the generator produce the DC electricity. In the alternator, the coil is rotating. In the generator, the coil is stationary. In the alternator, the magnetic field is stationary, and in the generator, the magnetic field is moving. These are the references. Thank you.